right, so let's go ahead and start talking about, let's go ahead and start talking about going over this. If you're still working on it, stop, come back and join us, because I'll give you time to continue as we go. But some of you are progressing quickly, some of you are like just completely stuck and stymied. Just so we're all on the same page, I want to make sure you understand where things are found on your Schoology page. It's hard for me to hear comments from people who say, well, it wasn't posted, I didn't know where it was. So we need to continue going through this until everybody knows where to find the stuff that we post. So when you get to our Schoology page, each unit is listed individually. Whichever unit we're currently in, I bump up to the top so that you can see it when you log in. So when you click on that unit, within this yellow folder is all the PDFs of the notes that you are handed in class. So you really don't need any of this unless you're absent. Because if you received a copy of it in class, then you don't need another copy. Now, I did have a kid one time who went back through and printed out at home blank copies of everything and practiced filling in the answers as a study strategy, which I thought was great, if that's your jam. All right, so the homework assignments are always listed here, and the homework assignments have the due dates individualized for whichever period you are, and again, a PDF of what the assignment is. These are listed separately, not stuck in the folder, and my intent in doing this way is so that you can see the homework, the due date, and have quicker access to it. Any video that you need is found under this link. Now, the reason why it's just one link is because I set up a playlist for each unit. So anytime you want to see a video for our class or the lesson, I have them all labeled. 6-0 was that introductory lesson. Here's 6-1 notes. Here's 6-2 notes. And sometimes if I get a different video on my odd and even days, I'll post them both. So the date of the class, what we did, similarities, scale models, and the different notes. That way, if you're ever absent from class, it's an easy find where you can scroll through. The playlist gives you access to all of the ones from that unit, and you can see how long they are. You can click on them and see when I posted them. So these ones, 6-1 notes. It's a little bit upsetting to me that out of my 80 Geometry Honors students, 27 people have watched the video that I posted on January 19th. If you are ever in the position of needing and wanting information and you can't find it, please email me. My emails go to my phone. Rule of thumb, I only answer emails during the hours I'm paid to answer emails. But if it's something where I can't find this and I need it, and if I see it on my phone, I'll be glad to help you out and tell you where things are located. Sound okay? All right. So let's get back to talking about our quiz warm-up. We allocated 30 minutes for the quiz. It took me like 9 or 10 times 3 gives you 30. It's my rule of thumb. Mr. Logan said his classes took a little bit longer, so I ended up switching the lunches for my 5th period, so they had longer to take it, and most of them did need at least 40 minutes. So I need to be careful watching the clock, making sure that we don't review too long, and that you get enough time to complete your work. Sound okay? All right, so here we go. I gave you 3 different types of proportions, and what I want, each one is targeted with something you need to review. Number 1, did you make sure you bubble wrapped this? Did you make sure that you used cross products to solve? Did you make sure you used the distributive property? Did you combine like terms? And even if your answer is not something pretty, it's okay. When we're dealing with a unit on ratios, if it doesn't come out perfect, that's okay. Negative 14 to 3, there's nothing wrong with that. It's not as pretty as we like, but it still works. It's a good answer. Please do not give me that answer as a decimal. If you give me that answer as a decimal and you have negative 14 divided by 3, that is a repeating decimal that the minute I stopped writing 66666, I compromised the true value of that number. If you're worried about whether or not your ratio or your fraction is in simplest form, your calculator has the ability to do that for you. If you check this button here, math, choice number 1 is frac, and then you press enter, and it will, if this was not in simplest form, it will give it to you in simplest form. So would you check in with your partners right now and make sure that they know where math frac is located? All right, next up, we have a problem where x times x is x squared, and 4 times 12 is going to be 48. When I go to solve a problem with a perfect square, I'm going to go ahead and take the square root of each side, which means that x is going to be equal to, whenever I draw the square root sign, I have to recognize that either a positive or a negative number could be a potential value depending upon the context of my problem. Now in geometry, most of the times will end up not including the negative because that is one of those extraneous solutions. If I'm talking about distance can't be negative, it's the absolute value. But in good practice, when we have no context for the problem, we're always going to include the plus or minus to make sure that we recognize that a negative value could have been squared, that x could have been negative, and then that proportion would still be true. When I go to simplify my radical, I want to go ahead and break it down into values that I know are perfect squares. If I kept it with 4 times 12, I know that 12 breaks down into 4 times 3. These double factors can come out of the radical sign. I'm looking for perfect squares. I'm looking for radicals that I can simplify. I'm looking for double factors so that my x would be equal to plus or minus 4 times the square root of 3. All right, next up, what I want you to get on this one is sometimes the whole numbers mess up kids. So what we want you to remember is you can put anything over 1 and still do your cross products. 6 times 1 is 6. Bubble wrap this. 3 times x minus 6. 6 is equal to 3x minus 18. 3x is equal to 24. X is then equal to 8. So each of those 3 examples is something about solving proportions involving variables in the denominator. If I have a double variable and I end up with a quadratic, taking the square root of each side, and then making sure I bubble wrap. Would you please turn to your group mates and say which one of these 3 you want to make sure you don't forget for the quiz? Go.
Keep on forgetting that. It's like really the easiest way to do anything.
All right, come back. Come back. So lots of questions about what is the geometric mean? What does the geometric mean, Mrs. Glazier? Can you explain to me what the geometric mean is? So if you look on the back of notes 6-1, that is where we talked about what the geometric mean is. The geometric mean is a value for x such that x exists in that denominator of my first fraction, numerator of my second fraction, and its value is the square root of the product of the extremes. So that's on the back of that note 6-1. When we talked about all of these properties of proportions. So when I go to find the geometric mean, it helps me to set up a template that looks like this. And I know I'm solving for this value that exists in the numerator of one fraction and the denominator of the other. So when I'm asked to find the geometric mean of two numbers, it doesn't matter where I put those numbers. 4 here or here doesn't matter, because when I go to solve it, you know I go and think about my cross products. X squared is equal to 100. When I take the square root of each side, I end up with x is equal to 10. Now typically lots of hands go in the air. You're like, you forgot your plus or minus. I didn't, because the geometric mean is always positive. So if I'm told it's the mean that I'm solving for, it stays positive. If I have a problem with x's in those parts of the fractions and nobody tells me the context, I have to include both. So number 5 takes that same conversation about geometric mean, but now instead of not knowing what it is, this time they tell me it is 12. So if 12 is my geometric mean, he's going to sit in this ratio such that he's in the denominator of one fraction and the numerator of the other. So 12 is the geometric mean of 4 and what other number? Now again, nobody cares if I put 4 here or here, because at the end of the day, when I go to solve it, I'm finding my cross products. So I know that 4 times x is 144. So I know that 144 divided by 4 is equal to 36. So 36 and 4 have a geometric mean of 12. So lots of questions out there about the geometric mean. Turn to your group mates right now and make sure everybody gets it and what it means. And Marcus, like, go.
I understand. Yeah. Okay. So. Relax. Okay.
All right, come back. So in our class activity, we had a comic, and that comic was, we'll just say 6 by 8. And I want to know what the poster is outside. Well, when I look at each of our squares, we had a 1-inch square, and we blew it up to an 8.5 inch by 8.5 inch square. This is our scale factor, 1 to 8.5. Now there's a difference between your scale factor and your scalar, because small to big was 1 to 8.5, but you need to think about, what do I need to do to each of these values to equal the size of our big class poster? So if our class poster has this length and width, I know that 6 to the length is going to be equal to the same ratio as 1 to 8.5. If I'm solving for the width, I can say that the little to the big has the same story as the little to the big. Notice for each of those separate ratios to solve for my length to length, my width to width, I'm doing little to big, and here's the story, little to big. What you end up realizing is I end up with a scalar of multiplying each of these values by 8.5. So 6 times 8.5 is 51. Therefore, my length is equal to 51 inches. 8 times 8.5 is equal to 68. Therefore, my width is 68 inches. So we want to make sure we understand the difference between scale factor 1 to 8.5 and our scalar. What is it that I need to multiply my little by to equal my big? Did you see your poster out there? It looks pretty good, doesn't it? It's on the outside of the wall. You have to check it out when you go to leave at the end of the day. All right, here's this next sentence. Given these two triangles are similar, go ahead and solve for x. When I match up my corresponding sides, I know that AB corresponds to DE. So I know that 13 can be compared to 27. I know that BC and EF correspond. So 21 can be compared to x. I'm allowed to set up these proportions because I was given that the triangles were similar. So 13 x's is equal to 27 times 21. 567 divide by 13, divide by 13. When I take this and I divide by 13, I get a real ugly decimal. Math frac enter. It comes back to that original decimal or fraction. So that means that that is both those values do not have any friendly numbers where I can simplify the fraction.
You're writing 576, supposed to be 567.
What? Thanks, Donovan. You can put a Smarty up. Here we go. All right, would you please scan through this first page and tell your group mates, now I'm glad we did this kind of problem because I'll know what to do. Go.
That blew my freaking mind. Okay, so you're gonna have your problem, right? So
All right, come back, flip the paper over. So the last problem, we told you they were similar. But now we need you to take a look at the next two and justify or prove whether or not they are similar. Okay, well, when I talk about similarity, we can talk about angle-angle similarity. We can talk about side-angle-side similarity. And we can talk about side-side-side similarity. And what you need to know is anytime I'm having a conversation about the sides, we need to make sure that those sides are in a proportional relationship to each other. Now, if they're congruent, it's a one-to-one relationship, so all congruent triangles are also similar. So similarity is the overarching, congruent is most specific. I don't bother with angle side angle or angle angle side because it's two angles and I already have that through angle angle, so we don't bother doing anything. The only time I need my sides is when I'm left with just one angle. If I have one angle, I'm going to need some sides. If I have two sides and the included angle, that'll work. If it's not the included angle, it doesn't work. and side, side, side proportional. Which one do you think I'm going to be using on this one? Yeah, side, 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 because check it out, I don't have any angles. So here's how you know what matches up with what. So the distance from A to B corresponds to the distance from D to E because that says so in my similarity statement. So AB is 12, DE is 20. Let's see what that simplifies to. 12 divided by 20, 0.6, math frac, enter, 3/5. So if you struggle with fractions, the calculator can help you see that the distance from A to B compared to the distance from D to E is 12 to 20, which simplifies to 3/5. With your group mates, please discuss the other two sides and confirm that they also, or do not, have a relationship of 3 to 5. Go. All right, do we agree? When I look at small to big, small to big, small to big, I get the same thing each time. Over here we had a conversation about, well, what if I ended up with 5/3? That's okay, as long as you did it consistently each time. If you compared this to this, and this to this, and this to this, you would have gotten 5/3 for every single one of them. That's good. But make sure that you don't mess up your order. Because you don't want to be looking at 5/3 and 3/5 and be like, nope, they don't match. You want to make sure you're consistent in the order that you compare things. Sound okay? All right. So when we take, go ahead.
Look, I did 6/9 and 10/15, and I got, they both were equal. Does that still count or no?
So if you did 6/9 and 10/15, you found the relationship between these are the same, but you need to keep going because you need all three sides to have the same story. So just having one relationship within the triangles is not enough. You need to do that for all of them. Does that make sense? So it's easiest to make sure that you do it between corresponding sides. All right. So when I look at this next one, I'm again given these two triangles to see if they're similar. And I want you to be careful about which triangles I'm talking about. I'm talking about triangles A, B, C. Do you see this little triangle here? And if it's easier for you to draw it, please do. And next I'm talking about triangle ADE. See this big triangle here? And if it's easier for you to draw it, please do. Both of those triangles share angle A. What else do I know about those triangles? Anybody? What else do I know? Yeah, they both have right angles. So if they both have right angles, and I know all right angles are congruent, I know right away I've got angle-angle similarity. That's all I need. I don't even need to mess with the sides. Don't even bother. Because for this one, I've got angle-angle similarity, not a problem. So when they want me to calculate the scale factor, let's take a look at the measurements. I've got a measurement of 6 here. What is the length of this corresponding side? Yeah. Make sure you do 18. Because 6 to 18 is going to give me a scale factor of 1 to 3. For every one measurement in this triangle, there are 3 in this one. So if I need to figure out what h is equal to, here's my h. That's this side here of this triangle, and that's going to correspond to 9/10 of a meter over here. So when I go to set up my proportion, 9/10 is to h. as 1:3. I could have done 6:18. I prefer to work in smaller numbers. So that means my H has a value of 2.7 meters. If you're given units, make sure your answers include units. That's super important. So the lengths of the sides of the triangle are in the extended ratio of 2:5:7. One of the kids last period was like, "You did it again. That's not even a triangle." And I was like, "Wait. You're right. That's not a triangle." So we'll just pretend and do the math as somebody made up. All right, if I know my perimeter is 98 centimeters. So 2 plus 5 plus 7 in no world is 98. So that means that those ratios had to have been simplified by some factor. If we let x equal that factor, then we can figure out what each was multiplied by. And name that scalar. Fourteen x's is 98. Once I do this calculation to figure out what x is equal to, I substitute back into my problem. 2 times 7 is 14. 5 times 7 is 35. 10 times 7 is 69. Therefore, and make sure you use your units. Yeah. Am I okay? All right, these will be the problems that'll get you. And there's always one kid who's like, wait, what? So I want to make sure that you understand how to do these. Somebody's going to put this on a quiz, a problem like this, and say the answer is 6. Don't be that kid. Because we cannot say that that ratio, 12 hours to 2 days, is the same as 6. 12 days to 2 days is 6. 12 hours to 2 hours is 6. But what I need here is a conversion factor. And what my conversion factor does is it puts everything in terms of the same units. Now, how many hours are in a day?
23 and a half.
One day is 24 hours. My conversion factor has a value of 1. And I know which one goes where because I want them to be opposites. I want the units to cancel out when I multiply. Because I'm talking about hours in each day, hours in each day. Multiplying fractions is no problem. Top times top, bottom times bottom. So that's going to give me 12 over 48. 12 divided by 48, math frac, 1/4. So if that math frac thing is new to you, practice it now so you can use it during the quiz. Go.
Would it be 1 hour to 4 hours, or would it be 1 to 4?
So what we've done is I've removed units
You
from the
remove the units
conversation,
completely.
so it's 1 to 4. If you wanna talk about 1 day to 4 days, if you wanna talk about 1 hour to 4 hours, that story is 1 to 4. Cause I've removed the units by canceling them out. Does that make sense? All right, now that you see how to do it, check in with your group mates on the last 2 on your market set go.
Because you can obviously 30 every day, so you can cancel out.
Yeah, no, yeah, cause Fox.
10 times 3 because there's
No,
one
in
day,
order
24 hours in one day. That's 3. You can simplify that to 9.
Oh,
That's 27. Yeah, you're right. Everyone's stupid. I agree. The only reason that you're any different than
How'd you do?
we have a
Did you get 'em?
something.
All right.
You might not want to know all the time.
So take out your homework for 2. What'd I do wrong?
You didn't do anything
Aren't there 3 feet for every 1 yard?
wrong. No.
No, there's not 3 feet in a yard?
You're not crossing the line.
I'm not cross multiplying because there's no equal sign. Multiplying fractions is no problem, top times top, bottom times bottom. My units are canceling out. My units cancel out. Alright, take out homework 6-2. Did everybody get a key? Let me know what you need.
You get it.
Help on? Alright, let's talk about this first page. Anybody have any questions on this first page that they want to talk about? Are you okay with the difference between the ratio, the scale factor, and the scalar? So when you're talking about the scale factor of this shape to this shape, it has a 3 to 2 story. If I wanted to know what the scalar was to have to multiply it, you'd have to multiply this value by 2/3 to make it smaller. So think about whether you're going big to small or small to big. If you're taking a quiz and you need clarification, you can ask. Similar shapes, pictures, make sure you include units. Anything on that first page, front or back side you want to talk about? Go ahead.
Can you do the last one, 5 on the
5 on this one? Okay. In the diagram, these 2 are similar. So these 2 are similar. So if I want to find the length of MS, I know that I have a relationship 30 to 18 for the similar figures. So that means that 12 and X are going to have that same relationship. So I went big to small and big to small. I could have also done 15 to 9. That would have worked out fine. I would have gotten the same answer. Anything on the back of page 1 you want to talk about? Go ahead.
I have a question about one thing. So when you're doing proportions, do we, let's just say 6 and 13 are corresponding. We put 6 over 13.
It doesn't matter whichever way that you're doing it, just be consistent in how you're doing it.
And we multiply 6 by the so we don't multiply by the same side on that triangle. So 6 is on the same triangle as 27.
Okay.
Multiply it together.
So take a look at this triangle here. So this triangle here has sides 8 and 10. This triangle here has sides 11 and x. I compare 8 to 10 as 11 to x. I could have also written this as 8 to 11 and 10 to x. So if I had wanted to write this proportion as 8 to 11 is the same as 10 to x, both of these proportions are good because they both have me multiplying across the equal sign. 8x is equal to 110. So there's two ways that you can write every story. Are you comparing the relationship between the sides like you were talking about before? Or are you going from one figure to the next, 8 to 11? Go.
Where did you get 11?
Isn't 8 plus 3 11?
Oh.
Isn't that the side of this triangle? Okay. All right, the back, the second page. The two triangles that are similar are the ones that have the same proportion through all the sides. My ramp has to be 30 feet long. Vertical angles, in addition to the corresponding relationship between my sides, side angle side. Similar triangles. And you were supposed to write a similarity statement here. So what I needed to see was triangle ABE similar to triangle CDE. And then the two proofs on the back, which we talked about when we were together in class. So they should be okay. All right. When you finish your quiz, you're going to pick up this piece of paper. So I want to talk about this in a minute. Can I please